Imagine looking up at the night sky and choosing one faint blur that does not belong to our own galaxy. Not a star, not a planet, not a nearby cloud of gas glowing inside the Milky Way. A whole other island of stars, hanging so far away that its light began crossing the dark, long before recorded history, long before cities, long before telescopes, long before anyone on Earth knew that other galaxies existed at all. That blur is Andromeda. It is the nearest large galaxy to the Milky Way, and it is close enough to be seen with human eyes from a dark sky. But that word, close, is almost misleading. Andromeda is close only by the brutal standards of galaxies. For a spacecraft, for a human life, for anything built by hands on Earth, it is not close in any ordinary sense. It is a destination so distant that even light needs about 2.5 million years to travel from there to here. So if humans ever tried to go there, the journey would not feel like crossing space. It would feel like leaving the human scale behind. Before we begin, if you enjoy calm journeys through the deepest parts of space, take a moment to subscribe, leave a like, and write in the comments where you are watching from and what time it is for you right now. It is strange to think that people in different places, under different skies, can all look up at the same universe together. Tonight, you are watching the Space for Sleep channel, talking about the terrifying journey to Andromeda. And to understand why that journey is terrifying, we have to begin not with Andromeda, but with the small world we would have to leave behind. Earth makes distance feel smaller than it really is. A plane can cross an ocean in a few hours. A message can reach the other side of the planet almost instantly. A city that once felt impossibly far can become a place on a screen, a route on a map, a ticket in an inbox. Modern life trains the mind to believe that distance can be defeated by better machines. Space does not cooperate with that feeling. Above the atmosphere, distance stops being a problem of fuel and becomes a problem of time. The moon is already far enough that every Apollo astronaut had to cross more emptiness than any human had ever crossed before. Mars is far enough that radio messages can take minutes to travel each way. The outer planets are so remote that spacecraft missions are measured in decades. Voyager 1 has been traveling since 1977, and after all that time, it has only reached interstellar space just beyond the protective bubble of the Sun. That is impressive. It is also humbling, because Andromeda is not beyond the Moon, beyond Mars, or beyond Neptune. It is not merely outside the solar system. It is outside the Milky Way entirely, across the dark space between major galaxies. A journey to Andromeda would begin like a normal launch, with fire, vibration, noise, and Earth falling away below. But almost immediately the scale would change. The ship would pass the altitude where satellites orbit, then the distance of the Moon, then the region where human beings have been before. After that, every hour would carry it farther into a story without precedent. The first, terrifying truth is simple. Almost everything humans have ever called far away is still basically next door. The Moon sits about 384,000 kilometers from Earth, on average. That number is large enough to feel cosmic, but it is tiny beside even the nearest planet. Mars can come within tens of millions of kilometers, and at other times, it is much farther. Jupiter is hundreds of millions of kilometers away. Neptune is billions of kilometers from the Sun. Those numbers sound enormous, and they are, but they are still solar system numbers. They belong to a region ruled by one star. Andromeda lives in a different category. Astronomers usually describe its distance as about 2.5 million light-years. A light-year is not a unit of time. It is the distance light travels in 1 year, moving at about 300,000 kilometers every second. In 1 second, light can circle Earth more than 7 times. In 1 year, It crosses almost 9.5 trillion kilometers. Now imagine that distance. Then multiply it by 2.5 million. That is the distance to Andromeda. The number becomes too large to picture directly, so the mind tries to compress it. It becomes a phrase, a label, a fact. But the journey would not be compressed. Every kilometer would still have to be crossed. Every stretch of blackness would still be there. Even if a spacecraft could travel faster than anything we have ever built, Andromeda would remain almost absurdly distant. If it moved at the speed of Voyager 1, the trip would not take thousands of years. It would not take millions. It would take tens of billions of years, longer than the current age of the universe. That is why the journey is terrifying before anything dangerous happens. The first enemy is not radiation, not cold, not mechanical failure. It is the scale itself. A real voyage to Andromeda would probably not begin with a ship built like anything we recognize today. Chemical rockets are powerful enough to escape Earth, but not powerful enough to make galaxy travel practical. Ion engines are efficient, but slow. Nuclear propulsion might shorten some interplanetary missions, but it still would not turn Andromeda into a human destination. Even a futuristic fusion drive would be forced to confront the same wall. Stars are separated by light years, galaxies by millions of them. So when we imagine the journey, we are already imagining a civilization far beyond our own. Maybe the travelers would not be individual astronauts in a capsule. Maybe the ship would be a city. Maybe it would be a fleet. Maybe humans would not travel as adult bodies at all, but as embryos, digital minds, suspended cells, or something stranger that future technology makes possible. But the terror remains, because every solution changes what the journey means. If the ship carries living generations, then the original crew will die long before reaching even the far edge of the Milky Way. Their children will inherit a mission they did not choose. Their grandchildren may see Earth only as an archive. After enough time, the ship stops being a vehicle and becomes a world with its own language, rituals, mistakes, and fears. If the passengers are frozen or suspended, the journey becomes a gamble with machines. Everyone sleeps while time erases the civilization that launched them. They may wake to find that Earth is gone, changed beyond recognition, or no longer listening. If minds are uploaded, then the question becomes colder. What exactly arrives at Andromeda? A human being, or a memory of one? For this first part of the journey, let us keep the idea simple. Imagine a vessel large enough to support human life for an unimaginable duration. It has rotating habitats for gravity, thick radiation shielding, closed ecological systems, repair drones, stored genetic libraries, and engines that can push it to a fraction of the speed of light. Not faster than light, not magic, just far beyond anything humanity can build today. Even then, the journey would still be terrifying. At 10% of the speed of light, which is already an extraordinary speed for a massive spacecraft, reaching Andromeda would take roughly 25 million years from the traveler's outside perspective. At 1% of light speed, it would take about 250 million years. At speeds closer to our current spacecraft, the timeline becomes so vast that it loses human meaning. So the ship would need to be less like a vehicle and more like a self-contained civilization. It would need to survive longer than mountains, longer than species, longer than many entire branches of life on Earth. Think about that quietly. A ship leaves Earth with the intention of reaching another galaxy, but the voyage is so long that the planet it left behind may become unrecognizable before the mission has crossed even a tiny fraction of the distance. Continents drift, climates shift, stars move, languages vanish. If there are people on Earth when the ship finally reaches its destination, they may not resemble the people who built it. The terrifying part is not only how far Andromeda is, it is how much time must be sacrificed to reach it. A journey between galaxies is not just travel through space. It is travel through extinction, memory, and change. The ship would first pass through familiar territory, at least by astronomical standards. It would leave Earth behind, cross the orbit of the Moon, pass the paths of Mars and Jupiter, and push outward through the solar system. The Sun would shrink slowly. At first, it would still dominate everything. Its light would still cast shadows. Its gravity would still rule the trajectory. Its storms would still matter. But the ship would keep going. Past Saturn, the Sun would become less warm and more like a bright command. Past Uranus and Neptune, it would no longer feel like the center of life. It would be a brilliant star behind the ship, still powerful, but emotionally changed. The planets would become points, then memories, then data. The outer solar system is not empty. It contains icy worlds, dwarf planets, scattered objects, and ancient remnants left over from the formation of the Sun. Pluto, Eris, Sedna, and countless smaller bodies drift through the cold. Some are known, most are not. A ship leaving the solar system would pass through a graveyard of frozen beginnings. These objects are terrifying in a quiet way. They are leftovers from the original construction site of our planetary system. They have been in darkness for billions of years, preserving chemical histories older than Earth's forests, older than animals, older than the first cells that learned to divide in ancient oceans. A journey to Andromeda would turn these distant bodies into the last familiar stones of home. After them, there would be no planets of the Sun ahead, only the slow, thinning edge of the solar system and the first true taste of interstellar space. The solar system does not end with a wall. There is no glowing border where sunlight stops and the rest of the galaxy begins. Instead, the Sun creates a bubble, a vast region shaped by the solar wind. Charged particles stream outward from the Sun in every direction, pushing against the material between stars. This bubble is called the heliosphere. Voyager 1 crossed the heliopause, the outer boundary of that bubble. In 2012, it became the first spacecraft to enter interstellar space. Voyager 2 followed later. These crossings were not marked by a camera looking back and seeing a line. They were measured through particles, fields, and plasma. The Sun's influence weakened. Cosmic rays increased. The surrounding environment changed. A ship heading to Andromeda would pass that region early in its journey, almost immediately compared with the full voyage. Yet emotionally, the heliopause would be enormous. It would be the place where the Sun stopped being the immediate environment and became a star behind you. The place where the ship left the protective wind of its parent system. The place where Earth's star no longer filled space with a familiar stream of particles, but became one source among billions. Beyond the heliopause, the ship would still not be outside the Sun's gravity entirely. Farther out lies the possible Oort cloud, a vast, distant reservoir of icy bodies that may extend far into space. Comets from this region can fall inward after being disturbed by passing stars or galactic tides. Crossing the Oort cloud could take thousands of years, and that would still only be the departure gate. Inside the Oort cloud, the ship might pass near worlds so dark that they would be almost invisible until the last moment. Not planets with skies, not moons with familiar craters, frozen nuclei of comets, scattered pieces of ancient ice, carbon-rich dust, and strange objects that have spent nearly their entire existence in deep cold. Their surfaces would be blackened by radiation. Their interiors might preserve materials from the early solar nebula. Some could be only a few kilometers wide. Others might be far larger, hidden in the immense distance. A generation ship would need to treat this region carefully. At ordinary human speeds, space debris feels harmless because space is vast. At a significant fraction of light speed, even a small grain becomes dangerous. A pebble striking the ship could release energy like an explosion. A dust particle could damage delicate instruments. A cloud of fragments could be deadly if the ship has no warning. So the vessel would not simply point toward Andromeda and accelerate. It would need a forward shield. It would need radar and LiDAR systems far beyond current technology. It might send small probes ahead to map hazards. It might use magnetic fields, plasma shields, sacrificial armor, or layers of ice and metal to absorb impacts. The terrifying thing is that the travelers would never see most of the threats with their eyes. There would be no asteroid field like in fiction. No dramatic swarm of rocks turning slowly in the sunlight. The danger would be quieter. A small object, black as the background, moving relative to the ship, at a speed that turns dust into weaponry. In deep space, danger does not need to be large. It only needs velocity. After the outer comet cloud, the ship would enter a more honest darkness. This is interstellar space. Not the space between planets, where one star still dominates. Not the cold space between the outer worlds of the solar system. The real medium between stars. It is not perfectly empty. It contains atoms, ions, dust grains, magnetic fields, cosmic rays, and thin clouds of gas. But compared with air, or oceans, or even the most delicate laboratory vacuum on Earth, it is almost nothing. If you could stand outside the ship, which you could not, there would be no wind, no sound, no horizon. The sun behind you would look like a bright star. The stars ahead would not appear to rush closer. The galaxy would remain wide and still. This is one of the strangest parts of very long space travel. Even at incredible speeds, the sky changes slowly. Humans are used to motion that reveals itself. Trees pass by a car window. Clouds move outside an aircraft. A coastline bends as a ship sails along it. In interstellar space, motion can be real and enormous, yet almost invisible. The distances are so large that even years of travel may change the view only slightly. A generation ship traveling toward Andromeda might cross enough distance to make the sun fade into the background. But for the people on board, day after day could look almost identical. The journey would be terrifying, not because every moment is violent. It would be terrifying because almost nothing happens, and yet everything familiar is being left behind. The first star the ship passes would depend on its course. If it left the solar system in the direction of Andromeda, it would not necessarily pass close to the nearest stars. Space is three-dimensional, and aiming at another galaxy is not the same as touring nearby systems. The ship might choose to visit stars along the way for fuel, repairs, or scientific reasons. Or it might avoid them, staying on a cleaner, faster path through thinner space. Every nearby star would be a temptation. A red dwarf might offer planets, comets, frozen resources, and a chance to stop. A white dwarf might offer a strange graveyard of worlds. A binary system might provide gravitational assists or hazards. A young, active star could be too violent to approach. But stopping is costly. Any detour consumes time. Any braking maneuver requires energy. Every pause turns an already impossible journey into an even longer one. For a mission to Andromeda, a star system could become a trap simply because it is interesting. Imagine a ship that has traveled for thousands of years and finds a rocky planet around a red dwarf. It is not Earth. Maybe the star flares. Maybe the atmosphere is thin. Maybe the planet is tidally locked, with one side facing eternal day and the other frozen in permanent night. But it has ice. It has minerals. It has a place to build. Some descendants might ask the obvious question, why keep going? Why chase a galaxy millions of light years away when a possible home is here? The journey to Andromeda would not only test engines, it would test purpose. Purpose becomes fragile over time. The first crew may believe in the mission with absolute clarity. They remember Earth. They know why they left. They understand the calculations. the philosophy, the dream. Their children may inherit stories. Their grandchildren inherit rituals. Later generations inherit systems, schedules, and instructions written by people who have become almost mythological. After enough time, the word Andromeda might become less like a destination and more like a religion. A glowing symbol on screens, a promise carved into the ship's oldest chambers, a reason given to children when they ask why the stars outside never change. This is one of the most disturbing parts of intergalactic travel. The technology is only half the problem. The other half is keeping a civilization aligned for lengths of time longer than any civilization on Earth has survived. Empires collapse in centuries, languages transform, beliefs split, institutions decay, records are lost. Even when people stay on the same planet, with sunlight and oceans and a sky they can touch, they struggle to preserve a single purpose. Now imagine preserving one inside a metal world crossing darkness for millions of years. The ship would need law, education, culture, medicine, food production, waste recycling, conflict resolution, population control, and psychological meaning. It would need ways to prevent stagnation without encouraging rebellion that destroys the mission. It would need freedom without allowing the systems to be neglected. It would need memory without turning memory into worship. A journey to Andromeda might fail long before the engines fail. It might fail because human meaning cannot stretch that far. Even if the social structure survived, the ship itself would age. Every material changes over time. Metals fatigue, polymers break down, electronics degrade under radiation, seals leak, bearings wear, pipes corrode, software accumulates errors, sensors drift, filters clog, biological systems mutate. Microbes adapt to the environment humans build for themselves. A generation ship would need to be designed for continuous repair, not periodic maintenance like an aircraft, not scheduled refurbishment like a space station. Continuous renewal. Parts would need to be manufactured from raw materials. Machines would need to build machines that build other machines. Entire habitats might have to be replaced section by section, while people continue living inside them. The ship would become less like a single object and more like a living organism, always repairing its skin, organs, and bones. This creates a strange problem. After a long enough time, is it still the original ship? If every panel has been replaced, every wire remade, every computer upgraded, every garden replanted, every habitat resurfaced, what remains of the vessel that left Earth? Perhaps only the direction, the mission, the archive, the name. In deep time, even machines become historical processes. The terror is not one dramatic explosion. It is maintenance without end, a civilization trapped inside a structure that must never be allowed to grow old faster than it can heal. And outside that structure, there is nothing. No rescue dock, no planet nearby, no emergency landing. Only the thin dust of the galaxy and the silent pull of the far destination. Radiation would follow the ship everywhere. Inside the solar system, Earth's magnetic field and atmosphere protect life from much of the radiation environment. In deep space, those protections vanish. Cosmic rays come from beyond the solar system, from supernova remnants, active galaxies, and other extreme sources. High-energy particles can pass through shielding, damaging electronics and living tissue. Solar storms become less important as the ship leaves the sun behind, but galactic, cosmic radiation remains. Shielding helps, but shielding is heavy. A ship can use water, fuel, regolith, metal, magnetic fields, or layers of structure to reduce exposure. Living areas can be placed deep inside the vessel, surrounded by storage tanks and machinery. Rotating habitats can be designed with protected storm shelters. But no shield is perfect, especially across cosmic timescales. Radiation affects not only bodies, but inheritance. If the ship carries generations, then protecting DNA becomes crucial. Increased mutation rates could damage fertility, development, immune systems, and long-term health. Advanced medicine might repair some damage. Genetic screening could prevent some suffering. But that creates difficult ethical problems. Who decides what counts as acceptable risk? Who controls reproduction when the survival of the mission depends on population health? How much individual freedom survives inside a vessel where biology is part of infrastructure? The terrifying journey to Andromeda is not just a question of crossing distance. It is a question of keeping life stable while the universe continuously tries to edit it. Every cell in every person aboard becomes part of the mission. Every future child becomes both a human being and a fragile continuation of Earth's biology. The ship's sky would be artificial. That matters more than it sounds. On Earth, the sky is not only scenery, it is orientation. It gives time, weather, color, sunrise, sunset, seasons, clouds, storms, and a sense of scale. Even in cities, even indoors, the outside world quietly organizes human life. A generation ship must invent all of that. It can create a day-night cycle with lights. It can simulate seasons inside gardens. It can project stars on ceilings. It can play rain sounds, grow trees, circulate air, release scents, and design public spaces that feel open. But every part of that world is engineered. Nothing is free. Nothing arrives from the natural environment without maintenance. Over centuries, people born inside the ship may not feel deprived. To them, the artificial sky is normal. The rotation of habitats is gravity. The hum of machines is background weather. A wall of metal may feel as permanent as bedrock. A water recycling plant may feel as ordinary as a river. But the old archives would reveal something else. Blue horizons, ocean waves, cloud shadows moving across fields, lightning over mountains. People standing under a real atmosphere, breathing air they did not have to manufacture. Those images could become dangerous. They could inspire hope, grief, resentment, or longing for a world no one on board has seen. The ship would have to decide how much Earth to remember. Too little, and the mission loses its origin. Too much, and the passengers may feel imprisoned by comparison. Andromeda would be ahead, but Earth would haunt the vessel from behind. For a long time, the ship would remain inside the Milky Way. This is easy to forget, because Andromeda is another galaxy, so the mind imagines a quick departure from our own. But the Milky Way is enormous. NASA describes our galaxy as about 100,000 light-years across, filled with hundreds of billions of stars. The Sun is not near the center. It orbits roughly 26,000 light-years from the galactic center, embedded in one of the galaxy's spiral structures. A ship headed to Andromeda must first cross or climb through our own galactic environment. Depending on its path, it might pass through star-forming regions, open clusters, dark molecular clouds, or relatively empty stretches between spiral arms. It would have to navigate around massive stars, stellar remnants, neutron stars, black holes, and clouds of dust that could make travel at high speed more dangerous. The Milky Way is not a flat glowing disk like a picture on a wall. It is a gravitational system with depth. It has a bulge, spiral arms, a thin disk, a thick disk, a halo of old stars and globular clusters, streams of torn-apart dwarf galaxies, and a vast dark matter halo extending beyond the visible stars. The ship would not simply leave a bright circle behind. It would travel through layers of galactic history. Some stars it passes may be younger than Earth. Others may be older than the Sun by billions of years. Some may carry planets. Some may have already destroyed their planets. Some may be dead cores cooling in silence. Others may be waiting to explode. The terrifying journey to Andromeda begins by crossing the crowded memory of our own galaxy. The galactic disk would be the first immense region to cross. From inside it, the Milky Way does not look like a spiral. It looks like a band of light across the sky, because we are embedded within it, looking through the dense plane of stars, gas, and dust. A spacecraft moving outward would slowly change that perspective. The familiar band would shift. The shape of the galaxy would begin to reveal itself not as a mythic river overhead, but as a structure. That change might take far longer than any human institution has ever lasted. As the ship travels, the constellations would deform. Orion would not stay Orion. The Big Dipper would bend and dissolve. Familiar star patterns are only temporary arrangements seen from Earth at this particular time. Move far enough, or wait long enough, and the sky becomes a different map. For the travelers, astronomy would be practical. Star positions would mark progress. Pulsars could serve as navigation beacons. Spectra would reveal motion. Distant quasars might provide a stable reference frame. The ship would carry catalogs more detailed than anything we have today, constantly updating them as it moves. But there is something lonely about that. The more accurately the ship navigates, the more clearly it knows how far it still has to go. Every measurement becomes a reminder. Every improved map sharpens the distance. Andromeda may appear larger over cosmic time, but it would not rush toward them. The destination would remain patient, enormous, and almost indifferent. In a journey this long, precision does not comfort the traveler. It reveals the scale of the prism. Eventually, the ship might move away from the dense plane of the Milky Way and into the galactic halo. This is not empty space. The halo contains old stars, globular clusters, streams of stellar debris, hot gas, and dark matter. It surrounds the visible disk like a ghostly extension of the galaxy. If the disk is the bright city of the Milky Way, the halo is its ancient outskirts, full of ruins, wanderers, and invisible mass. Globular clusters would be among the most haunting sights. These are dense, spherical swarms of old stars, often containing hundreds of thousands or millions of them. Many formed early in the history of the galaxy. They orbit the Milky Way like relics, preserving a population of ancient stars that can be older than the galactic disk as we know it. If the ship passed near one, the sky could become crowded in a way no Earth night sky can match. Stars would fill space in all directions, packed so closely that darkness itself might seem weakened. Yet those stars would be old, metal-poor, and quiet compared with younger regions. Beautiful, but not necessarily welcoming. A globular cluster might offer resources, gravity, and scientific wonder. It might also be a trap. Dense stellar environments mean more gravitational perturbations, more close passes, more remnants, more radiation hazards, and less simple navigation. A ship designed to cross intergalactic space might avoid such places unless it needed them. The halo teaches a different lesson from the disk. Even at the edge of a galaxy, you are still inside its history. There would be no single day when the Milky Way ended. That is important. A galaxy fades outward. Its visible disk becomes thinner. Its halo stretches farther. Its dark matter influence reaches beyond what telescopes easily show. Its satellites orbit at huge distances. Its hot gas blends into the intergalactic medium. The boundary is not a wall, but a transition from belonging mostly to one galaxy to moving through the shared space of the local group. The local group is the small family of galaxies that includes the Milky Way, Andromeda, the Triangulum Galaxy, and many dwarf galaxies. It is not a random collection. Gravity binds it together. Andromeda and the Milky Way are the two largest members shaping the motions of smaller galaxies around them. A ship, leaving the Milky Way for Andromeda, is still not leaving all structure behind. It is crossing from one member of a galactic family toward another. It would pass through a region influenced by both galaxies, their dark matter halos, their satellite systems, and the quiet gravitational architecture between them. This makes the journey feel stranger. It is not like sailing from one island to another across a simple ocean. It is more like crossing from one enormous invisible atmosphere into another, with currents of gravity instead of water, and ancient dwarf galaxies instead of scattered rocks. The dark between the Milky Way and Andromeda is not blank. It is a territory we barely understand. And for a ship crossing it, the lack of clear borders would be unsettling. You would not know exactly when you had left home. You would only know that home had become smaller behind you. The sun, from that distance, would no longer be special to the eye. This may be one of the hardest emotional changes to accept. From Earth, the sun is not one star among many. It is daylight, warmth, weather, plants, food, time. It is the reason the sky changes from black to blue. It is so dominant that humans rarely think of it as a star in the ordinary sense. But from deep within the galactic halo, the sun would become a faint point hidden among other points. The ship's instruments could find it. Its records would identify it. Its history would keep it sacred. But visually, it would not rule the sky. A person looking through a telescope might see it as just another star, one small ember in the Milky Way's vast structure. That transformation is terrifying because it changes the meaning of origin. Earth is not carried physically with the travelers. The solar system is not nearby. The sun no longer commands their environment. The only thing connecting them to home is information. Stored images, preserved voices, genetic ancestry, cultural memory, and the direction behind them. At that point, Earth becomes an idea. A real planet, yes, but also a lost coordinate. If generations have passed, no one on board has walked there. If millions of years have passed, Earth itself may have changed beyond recognition. If the journey is long enough, the species on the ship may be the only surviving branch of humanity. The trip to Andromeda might become not an expedition from Earth, but an attempt by Earth to outlive itself. As the ship continues outward, the Milky Way would slowly become a complete object. This might be one of the most beautiful stages of the journey. For the first time, human eyes, or whatever replaces them, could look back and see our galaxy from the outside. Not as a band of light across a sky, not as maps reconstructed from star surveys, but as a spiral island, luminous and dusty, turning slowly in the dark. The central bulge would glow with older stars. Spiral arms would curve outward, traced by blue star-forming regions, pink nebulae, and dark lanes of dust. The sun's location would be impossible to spot without instruments. Earth would be beyond invisibility. All of human history would fit inside one unmarked point in one spiral arm. That view would be overwhelming. It would also be dangerous to romanticize. The ship would be looking back at light from the past. Depending on distance, the Milky Way seen from outside would not be perfectly current. Light takes time to cross even galactic scales. The ship's image of home would be delayed, layered, and incomplete. The galaxy itself would not remain still. Stars orbit, gas flows, clusters disperse, supernovae explode, black holes feed. Dwarf galaxies are torn apart. Everything that looks calm from far away is actually in motion. This is one of the strange cruelties of astronomy. The farther you travel, the more beautiful the view becomes, and the less immediate it is. At intergalactic distance, even home becomes a memory delivered by light. Looking ahead, Andromeda would still be distant. It would be larger than before, brighter perhaps, more detailed through the ship's instruments. But in the early phase of the galactic crossing, it would remain unimaginably far, a spiral shape in the dark, a future too large to hurry. Andromeda is not a single object in the simple sense. It is a galaxy containing perhaps around 1 trillion stars, with spiral arms, dust lanes, star clusters, nebulae, satellite galaxies, a central supermassive black hole, and a vast halo of gas. It is larger than the Milky Way in visible extent. It has a complicated history of mergers and interactions. It is approaching our galaxy, though recent analyses of the future Milky Way-Andromeda encounter show more uncertainty than older dramatic predictions suggested. A ship traveling toward it would not be aiming at a point. It would be aiming at a gravitational ecosystem. Long before reaching Andromeda's bright disk, the ship would eventually encounter its outer halo. That halo may stretch far beyond the visible galaxy, filled with hot gas and traces of material expelled by stars and supernovae. In fact, halos around galaxies can extend so far that the outer envelopes of the Milky Way and Andromeda may already be interacting in a broad sense. That idea is unsettling. The visible gap between galaxies looks empty, but their invisible outskirts can be enormous. The ship might enter Andromeda's extended influence before it reaches anything that looks like the galaxy in pictures. The terrifying part is that the destination begins before it appears to begin. But before that, the ship must face the longest darkness of the journey so far. The region between major galaxies is thinner than the space inside the Milky Way. There are fewer stars, fewer systems, fewer obvious places to stop. The matter there is diffuse, spread into gas, plasma, dark matter structures, and the faint debris of galactic history. There may be wandering stars, rogue planets, globular clusters, and dwarf galaxies, but they are separated by enormous distances. A generation ship crossing this region would have to become almost completely independent. In the galactic disk, there is at least the possibility of passing star systems. In the intergalactic gap, help becomes more abstract. You might see galaxies in every direction and still be nowhere near any usable resource. The sky could be filled with islands of light, but the local environment around the ship could be emptier than anything human beings have ever experienced. This is where the journey becomes psychologically different. Inside a galaxy, the ship is leaving one star for another potential star. Between galaxies, it is leaving the idea of nearby stars. The travelers may still see the Milky Way behind and Andromeda ahead, but both would be too remote to matter in a practical emergency. If a major system failed, there might be no place to obtain materials except whatever the ship carried. If a habitat collapsed, there might be no planet or asteroid nearby. If the engines failed completely, the vessel could drift for millions of years without reaching anything substantial. Intergalactic space does not need monsters. Its terror is the absence of options. This absence would shape every design choice. A ship crossing to Andromeda would need redundancy layered upon redundancy. Not one oxygen system, but many. Not one water cycle, but separate recoverable loops. Not one reactor, but multiple power sources that can be isolated, repaired, and replaced. Not one archive, but copies stored in different materials, different compartments, and possibly different biological and digital forms. The ship would need to survive mistakes. A fire cannot be allowed to destroy the mission. A disease cannot be allowed to collapse the population. A civil conflict cannot be allowed to ruin the engines. A software corruption cannot be allowed to erase navigation. A small impact cannot be allowed to open the ship like a shell. This creates a society built around prevention. Children might learn emergency procedures before they learn old Earth geography. Engineers might be honored like priests because they keep the world alive. Farmers, doctors, programmers, geneticists, psychologists, and maintenance crews would not be separate professions in the ordinary sense. They would be organs of the ship. Every meal would depend on ancient planning. Every breath would depend on machinery and biology working together. Every birth would be a question of population balance. Every death would be part of a closed system. Because on a true long-duration ship, even waste may become material. The journey to Andromeda turns civilization into life support, and life support into civilization. There is another problem. Speed changes time. If the ship could move close enough to the speed of light, time on board would pass more slowly relative to the outside universe. This is not science fiction. It is a consequence of special relativity. At ordinary speeds, the effect is tiny. At a significant fraction of light speed, it becomes important. At extreme speeds, near light speed, travelers could experience a shorter journey than observers back home. This sounds like an escape from the problem, but it creates new ones. To gain strong time dilation, the ship must travel extraordinarily fast, which requires enormous energy. It must accelerate without killing its passengers. It must shield itself from interstellar particles that strike with extreme force. It must eventually slow down, which may require as much planning and energy as speeding up. Even if the people on board experience less time, the universe outside still changes. And if the ship is a generation vessel rather than a near light-speed relativistic craft, time dilation may not save it at all. The terrifying truth is that physics offers loopholes in one place, while raising walls in another. Moving faster shortens subjective time, but makes impacts deadlier. Slowing down at the destination becomes harder. Navigation becomes more exacting. Energy demands rise beyond anything human civilization currently commands. The dream of Andromeda forces a choice. Travel slowly and let time consume the mission. Travel quickly and let energy, shielding, and relativity become the danger. There is no gentle path between galaxies. At high speed, even empty space becomes an environment. Atoms in the interstellar medium would slam into the forward shield. Dust grains would carry devastating energy. Radiation from the cosmic microwave background would be shifted toward higher energies in the ship's forward direction if the speed were extreme enough. The universe itself would become directionally hostile. The front of the ship might need to be a massive shield, perhaps separated from the living sections by long distances. It could be made of ice, magnetic fields, plasma, layered composites, or replaceable slabs of material mined and manufactured during earlier phases of the mission. Small probes might fly ahead, acting like scouts or sacrificial detectors. The ship may have to adjust course constantly to avoid dense regions of gas or dust. A journey to Andromeda is often imagined as empty and quiet. At sufficient speed, it becomes a storm. Not a storm of air or rain, but a storm made of particles that are normally harmless only because we move slowly compared with them. The faster the ship travels, the more the universe ahead is compressed into threat. This gives the journey an almost cruel balance. If the travelers go slowly, they face time. If they go quickly, they face the violence of matter. The safest speed may still be too slow to be meaningful. The meaningful speed may require engineering so advanced that the ship is no longer recognizable as a spacecraft. And even then, Andromeda waits millions of light years away. The ship's navigation would need to account for motion on every scale. Andromeda is moving. The Milky Way is moving. The Sun is orbiting the galaxy. Stars inside both galaxies move around their centers. The local group moves relative to larger cosmic structures. Space itself expands on cosmological scales, although inside gravitationally bound systems, like the local group, local gravity dominates over expansion. Aiming at Andromeda is not like aiming at a stationary target. It is more like aiming at a vast rotating storm that is itself moving through a web of gravity. Over long timescales, small errors grow. A tiny mistake in velocity, angle, or gravitational modeling could become a huge miss after millions of years. The ship would need autonomous navigation capable of updating its path across deep time. It could not depend on Earth for real-time instructions. Signals would take millions of years once the distance became galactic. Even early in the trip, delays would grow until conversation with home became impossible. This changes the idea of command. A spacecraft going to Mars can be guided from Earth, at least with delay. A probe going to the outer planets can receive mission updates. A ship going to Andromeda must become its own decision-maker. The crew, or their descendants, or the ship's intelligence, would have to decide when to adjust course, when to conserve fuel, when to avoid danger, when to approach a star, and when to continue without stopping. The journey would not just separate humans from Earth in distance, it would separate them from Earth's authority. As centuries stretch into millennia, and millennia into longer durations, information from Earth would arrive later and later. At first, messages might still matter. Updates, discoveries, warnings, cultural transmissions, perhaps even replies from families left behind. Then, delays would grow from hours to days, from days to years, from years to centuries. Eventually, any message from Earth would be historical by the time it arrived. News would become archaeology. The ship might receive a transmission announcing a discovery that had already become ancient. It might hear music from a civilization that no longer exists in that form. It might receive instructions from institutions that vanished long ago. It might watch Earth's languages change through signals, then perhaps stop receiving clear signals at all. The travelers would have to decide how to treat those messages. As guidance, as memory, as sacred relics, or as background noise from a place that can no longer help them. This is terrifying in a deeply human way. Exploration usually has a return path, or at least a shared present. A ship to Andromeda loses that. It becomes a branch broken from the trunk, still carrying the same genetic and cultural origin, but growing into something else. At some point, Earth would stop being the mission center. The mission center would be the ship. And that may be the moment when the journey truly leaves home, even if the Milky Way is still all around it. The first part of the voyage, then, is not simply a departure. It is a sequence of endings. The end of Earth as a nearby world, the end of the Moon as a destination, the end of the planets as reachable neighbors, the end of the Sun as an environment, the end of the solar system as home, the end of the Milky Way as a sky you live inside without seeing from the outside. Each ending is slow enough that no single day may feel historic. The ship does not cross a painted line. There is no ceremony forced by the universe. The passengers may create ceremonies themselves, marking distances, boundary crossings, final views, last messages, or the moment when the sun becomes too faint to distinguish without instruments. But the real change is cumulative. One day, the ship is still part of the solar story. Later, it is part of the stellar neighborhood. Later still, it belongs to the galaxy as a moving point. Then, after enough time, it begins to belong to the space between galaxies. That transition is difficult to imagine because human minds are built for local worlds. We understand rooms, roads, weather, families, countries, and lifetimes. A journey to Andromeda forces the mind into scales where all of those categories bend. It asks whether a civilization can remain itself after crossing distances that erase almost every practical connection to its origin. And by the time the Milky Way becomes an object behind the ship, that question can no longer be avoided. There is also the question of what the travelers would see when they look back. The Milky Way would not vanish suddenly. It would shrink into a grand spiral view, then a bright island, then a luminous structure among other structures. Its dust lanes and spiral arms would become easier to see from the outside, but harder to emotionally connect with. The galaxy would become more complete as an image and less reachable as a home. Andromeda ahead would grow slowly, very slowly, so slowly that generations might pass before the change is visible to the naked eye. Instruments would track it. Computers would display updated models. The destination would fill simulations long before it fills the actual sky. Children born on the ship might be shown enhanced images, orbital diagrams, approach plans, and maps of Andromeda's halo. But outside the windows, the galaxy would still seem distant. This gap between knowledge and experience could be difficult. The ship can know it is moving. It can prove it mathematically. It can measure the shift of stars, the changing angle, the growing detail of Andromeda. But the human body may feel no progress. The corridors remain the same. The artificial day rises and falls. The gardens need pruning. The water system needs inspection. Someone gets sick. Someone is born. Someone argues. Someone fixes a pump. Cosmic travel may be made of ordinary days inside impossible distance. That is one reason it is so terrifying. The universe does not provide dramatic music for the largest journeys. It provides time. In that time, Andromeda itself changes. The light arriving from Andromeda today left about 2.5 million years ago. The galaxy we see in telescopes is not exactly Andromeda as it is now. It is Andromeda as it was when early humans were still deep in prehistory on Earth. If a ship travels toward it, the destination is also evolving while the travelers move. Stars are born. Massive stars die. Supernovae enrich the gas. Clusters age. Dust shifts. Satellite galaxies interact. The central black hole waits. Andromeda is not a frozen target painted on the sky. It is alive with stellar processes, though on timescales too large for ordinary human perception. By the time any slow vessel arrived, the Andromeda it enters could be very different from the Andromeda it first aimed for. This matters for navigation, but also for meaning. A mission might be launched toward one vision of a galaxy, then arrive in another era of that galaxy's life. Star-forming regions may have changed. Some planets may have been destroyed. New stars may have ignited. Old maps may become historical documents rather than accurate guides. Every intergalactic journey is also a journey into the future of the destination. You do not merely cross to Andromeda. You cross to whatever Andromeda has become by the time you get there. And that future cannot be known completely before departure. For now, though, in the first half of this journey, the ship is still closer to departure than arrival. It has left the inner planets behind. It has crossed the outer cold of the solar system. It has passed the heliopause, moved through or beyond the ancient comet reservoir, and entered the larger galaxy. It has seen the sun shrink into a star, and the constellations lose their familiar shapes. It has learned that deep space is not empty enough to be safe, not full enough to feel alive, and not close enough to offer comfort. It has begun the long work of remaining a world. Everything depends on systems that cannot be allowed to fail. Everything depends on people who may not remember why the mission began in the same way the founders did. Everything depends on a direction across the sky, toward a galaxy that is both approaching us in cosmic terms and still almost unreachable by human means. The terrifying journey to Andromeda does not become terrifying only when Andromeda appears large in the windows. It is terrifying from the start because the first stage already demands more patience, engineering, memory, and identity than humanity has ever proven it can sustain. And still, the ship continues. Behind it, the Milky Way slowly gathers itself into a shape. Ahead of it, Andromeda waits as a pale spiral promise. Between them lies the dark road no human has ever crossed. And that is where the second half of the journey will truly begin. Because leaving the Milky Way is not the same as reaching Andromeda. It is only the moment when the travelers discover what it means to be between galaxies. No solar system nearby. No familiar stellar neighborhood. No sky shaped by home. Only the enormous quiet of the local group, the invisible pull of dark matter, the faint halos of galaxies, and the slow approach of a destination so large that it begins long before its stars are close. The ship would eventually enter regions where the Milky Way is behind it, as a complete galaxy, and Andromeda is ahead, as another. It would cross a darkness that is not empty, but sparse enough to make every resource feel final. It would move toward a halo of hot gas, ancient stars, satellite galaxies, and gravitational history. And if it survives that crossing, the most terrifying part may not be the distance it has traveled. It may be what it finds when Andromeda stops being a distant shape and becomes a place. For now, the journey has only reached the edge of home. The true intergalactic crossing still lies ahead, and the first thing it takes away is the illusion that distance can be understood. Inside the Milky Way, even in the loneliest regions, the ship still belongs to something familiar. There is still a galaxy around it. There are still stars on every side, even if many are faint. There are still old clusters, streams of broken dwarf galaxies, clouds of hot gas, dark matter holding everything together, and the long memory of the spiral system that made the sun. But beyond that, the journey becomes harder to imagine. Not because there is nothing there, because there is almost nothing close enough to matter. Between the Milky Way and Andromeda is not a clean, empty gap like a black ocean between two islands. It is a region inside the local group, shaped by gravity, filled with dark matter, crossed by faint gas, and haunted by small satellite galaxies that move like forgotten embers around the two great spirals. But compared with the interior of a galaxy, it is almost silent. The stars thin out, the old reference points fade. The Milky Way no longer stretches across the sky as a band of light. It becomes a complete object behind the ship, a pale, flattened storm of hundreds of billions of stars. For the first time, the travelers would not live inside the galaxy they came from. They would look back at it from outside, the way we look at Andromeda now. That view alone would change the mind. The night would no longer have a home direction. The sky would not be divided into familiar constellations. The old stories people gave to stars would become useless, because the stars themselves would no longer sit in the same pattern. Orion would not be Orion. Cassiopeia would not be a queen. The Southern Cross, the Big Dipper, and every ancient map drawn from Earth would slowly dissolve into geometry. The ship would become the only place where those old names still survived. On walls, in archives, in quiet lessons for children born far from planets, someone might still point to a simulated sky and say, this was what home looked like. Not because they could see it out the window anymore, but because memory needs shapes. A civilization that travels between galaxies, oceans, mountains, or weather. It can only carry records, language, rituals, and a careful decision not to forget. And that is one of the deepest terrors of the journey. The danger is not only outside the ship, it is inside time. A trip to Andromeda at any realistic speed would take so long that the first crew and the final crew would almost be different species culturally. Even if biology stayed the same, history would not. The people who arrived would inherit a mission they never chose. They would be born inside corridors built by ancestors whose graves had never touched soil. They would learn about Earth from images, about rain from recordings, about forests from old vocabulary, and about oceans from museums of sound. A generation ship is not just a machine that crosses distance. It is an argument with forgetting. Every century, the ship must convince itself again that the destination still matters. Every failure becomes a test of purpose. A cooling pump does not only threaten temperature, it threatens continuity. A cracked bearing in a rotating habitat does not only threaten gravity, it threatens births, bones, sleep, agriculture, and the rhythm by which people know a day has passed. A lost archive does not only erase data, it removes one thread connecting the living to the reason they are there. In intergalactic space, rescue is not delayed. It is impossible. There is no nearby station, no convenient asteroid field, no friendly moon, no emergency return to a planet. A ship between the Milky Way and Andromeda would be alone in a way no spacecraft has ever been alone. It would not simply be beyond the reach of help. It would be beyond the reach of any civilization that still thinks in ordinary human time. Radio signals sent backward would crawl across the dark at light speed, but even light would need millions of years to make the full journey. A message to Earth, if Earth still existed in any recognizable form, would become an archaeological object before it arrived. The people who sent it would be long dead. The society that received it might not speak the same language. It might not know the mission name. It might not be listening. Communication across intergalactic distance becomes less like conversation and more like throwing a sealed book into time. That changes the meaning of discovery. A scientist aboard the ship could make the greatest measurement in human history, record the structure of intergalactic gas, discover a strange dark matter stream, or map the faint halo of Andromeda from an angle no telescope near Earth could ever see. But the knowledge would not return home in any useful human lifetime. The discovery would belong first to the ship, not to Earth. Humanity would become distributed across time delays so large that common identity might fracture. A civilization on Earth, if it remained, would continue evolving without them. A civilization aboard the ship would adapt to metal, recycling loops, artificial gravity, dimmed corridors, controlled ecosystems, and a destination that grew larger only across thousands or millions of years. By the time the travelers reached the outer halo of Andromeda, Earth might be a legend, changed beyond recognition, abandoned, transformed, or gone. This is why the journey is terrifying even before anything dangerous appears. It asks whether a mission can outlive the culture that launched it. Beyond the Milky Way, the ship would pass through an environment that seems calm only because humans are not built to sense its violence. Intergalactic space is thin, but not harmless. High-energy cosmic rays still pass through it. Particles accelerated by distant supernovae, active galactic nuclei, and ancient magnetic fields would strike the hull over and over again. Some would be blocked. Some would create secondary radiation. Some would slowly damage electronics, materials, and living tissue. The ship would need shielding not for a weekend, not for a mission of a few years, but for ages. Every kilogram of shielding would have been paid for at launch. Every layer would matter. Water tanks, fuel reserves, soil, regolith, magnetic fields, superconducting systems, and thick structural walls could all become part of a protective design. But no protection is perfect forever. Radiation is patient. It does not need one catastrophic event if it has enough time to keep adding damage. Then there is dust. In ordinary imagination, dust sounds harmless. On Earth, it gathers on shelves. In deep space, dust becomes a bullet if the speed is high enough. A grain too small to see can hit with the energy of an explosive impact when a ship is moving at a meaningful fraction of light speed. A generation ship traveling to another galaxy would need forward shielding, detection systems, sacrificial layers, possibly magnetic or plasma defenses, and constant repair capability. The frightening part is that the ship would not always see danger coming. A small particle in black space offers no warning. By beauty, there is no dramatic asteroid tumbling slowly into view. There may only be a flash, a wound in the forward shield, a tremor in the structure, Then alarms waking a crew that has lived for centuries inside procedures written by people who knew they would never be there to use them. Intergalactic space is sparse, but the distances are so large that rare events become inevitable over long enough travel. A ship does not need to be unlucky every day. It only needs to be unlucky once in the wrong century. And still, the journey continues. For a very long time, Andromeda would not feel closer. This is one of the strange psychological facts of cosmic travel. The destination may be approaching every second, but the sky does not reward that progress quickly. On a human lifetime, a galaxy millions of light years away remains almost fixed. Even across many generations, the change would be subtle. It would grow, yes, but painfully slowly. It would brighten. Its spiral arms would become more distinct through instruments. Its halo would become easier to measure. Its satellite galaxies would separate into clearer relationships. But to human eyes, the destination would still seem impossibly far. The ship would have to measure progress with numbers, not with emotion. Distance remaining, velocity relative to the local group, fuel reserves, population health, shield erosion, agricultural yield, archive integrity, children born, children taught, children who believed. The journey to Andromeda would turn survival into a calendar. Somewhere far from the Milky Way's disk, the ship would begin to see both galaxies as large, separate structures. The Milky Way behind it, Andromeda ahead, Triangulum off to one side, and smaller companions scattered through the local group. From this position, humans would finally see what our galaxy really is. Not a ceiling, not a night sky, not the soft river of stars visible from a dark field on Earth, but a giant rotating system, with arms, dust lanes, star-forming regions, globular clusters, and an unseen halo far larger than the bright disk. The travelers would understand home more clearly after leaving it. That is not uncommon in astronomy. Sometimes distance is what makes truth visible. From inside the Milky Way, we struggle to map it because we are buried in its disk. Dust blocks our view. Stars overlap. Distances are difficult. But from outside, the galaxy would become a shape. The ship could look back and see a barred spiral, immense and delicate, with the sun's birthplace lost somewhere in one of its arms. The entire human story would fit inside a point too small to isolate. Andromeda, ahead, would grow into something even more overwhelming. It is not a single object like a planet. It is a civilization-scale landscape made of stars. Andromeda, also called M31, is the nearest large spiral galaxy to the Milky Way. It contains hundreds of billions, possibly around 1 trillion stars, depending on how its mass and faint outer regions are measured. It has spiral arms, dust lanes, star clusters, satellite galaxies, a central bulge, and a supermassive black hole in its core. It is not simply a larger version of a star system. It is an entire cosmic continent. Approaching it would not feel like approaching one destination. It would feel like approaching a universe inside the universe. Long before the ship reached Andromeda's bright disk, it would enter the galaxy's outer halo. This is one of the most important parts of the journey because a galaxy does not end where its bright stars appear to end. Around the visible disk is a vast halo of old stars, globular clusters, diffuse gas, dark matter, and debris from smaller galaxies. Andromeda has absorbed over billions of years. The first pieces of Andromeda might not be dramatic. There might be no glowing wall, no border, no sudden crossing line. Instead, instruments would begin to notice changes. The density of halo stars would rise. The chemical signatures of ancient stellar populations would shift. The distribution of gas would become more Andromeda-like than Milky Way-like. The ship would begin to pass through structures gravitationally tied to M31, even while the bright spiral disk still lay far ahead. This is how galaxies work. They are not solid islands. They have outskirts that stretch into darkness. The travelers might pass through stellar streams, long ribbons of stars left behind by dwarf galaxies, torn apart by Andromeda's gravity. These streams are cosmic fossils. Each one tells of a smaller galaxy that once had its own history, its own stars, perhaps its own planets, before being stretched into a trail and absorbed into something larger. Andromeda is beautiful from far away. Up close, it is also an empire of ruins. That is one of the reasons the journey becomes eerie. The ship is not entering untouched space. It is entering a galaxy with a violent past. Andromeda has grown by eating smaller systems. The Milky Way has done the same. Every large galaxy is partly a graveyard of galaxies that did not remain separate. The halo is not empty scenery. It is evidence of cosmic cannibalism. Somewhere in that halo, ancient stars could pass within a few light years of the ship. Globular clusters might appear like compact cities of old suns, containing hundreds of thousands of stars packed into a sphere. To human eyes, a globular cluster from nearby space would be breathtaking. A dense swarm of golden points, far brighter than the isolated stars of intergalactic darkness. But it would also be dangerous in a different way. Dense, stellar environments mean stronger gravitational complexity, more radiation sources, more ancient remnants, more dead stars, more possibilities for neutron stars, white dwarfs, stellar mass black holes, and strange, high-energy systems. A ship designed for a quiet cruise could not simply wander carelessly through such regions. It would need to choose trajectories with extreme caution. It would avoid dense clusters unless observation made the risk worthwhile. It would treat gravity not as scenery, but as terrain. And as the ship moved deeper into Andromeda's outskirts, the sky would change again. Behind it, the Milky Way would no longer dominate memory as much as view. Ahead, Andromeda's spiral disk would spread wider, sharper, and more detailed. Dust lanes would become visible, not as faint smudges, but as dark rivers crossing starlight. Star-forming regions would glow pink and blue in telescopes. Clusters would resolve into points. Satellite galaxies would no longer be separate, distant companions in a catalogue. They would become neighborhoods, each with its own orbit and history. The ship would begin to face the strange problem of abundance. For most of the crossing, there was almost nothing close enough to reach. Now, there would be too much. Too many stars, too many possible routes, too many gravitational fields, too many questions. Which star should the ship approach first? Which systems are safe? Which planets are stable? Which regions contain young, violent stars? Which older stars might host quiet worlds? Should the ship head toward the disk, the halo, a globular cluster, a satellite galaxy, or a star system selected long before arrival by telescopes from the Milky Way? That decision could divide the descendants of the original mission. After millions of years, if the trip were that long, the destination chosen at launch might no longer matter. The people aboard might feel that they, not the founders, have the right to choose. Some might want a planet. Some might want only a stable orbit around a quiet star. Some might fear landing because their entire civilization has adapted to a ship. Others might consider the ship a prison and the first planet a promised escape. Arrival may not unite people. It may create the deepest disagreement in the mission. A planet is not automatically a home. That is one of the most important lessons of interstellar travel. Finding a star system does not mean finding Earth. A world can be too hot, too cold, too dry, too wet, too toxic, too massive, too small, too irradiated, too unstable, too young, too old, or simply wrong in ways that no telescope predicted. A planet can look promising from light years away and become impossible when approached. Andromeda almost certainly contains countless planets, because planet formation appears to be common around stars. But common does not mean convenient. Even in the Milky Way, we know of thousands of exoplanets, yet none are confirmed as another Earth. Habitability is not a label that can be stamped on a world from a distance. It is a delicate combination of orbit, atmosphere, chemistry, water, magnetic environment, geology, stellar behavior, and time. A generation ship reaching Andromeda might find that the galaxy is full of worlds but not full of places to live. It may have crossed millions of light years only to discover that the first nearby systems are beautiful, useless, or lethal. That is terrifying in a quiet way. The destination was never one galaxy. The destination was one survivable place inside it. And that place might still be far away. Suppose the ship enters Andromeda's halo and chooses a calm red dwarf system. The star is old, dim, and long-lived. Its planets are easier to warm if they orbit close, but close orbits bring problems: tidal locking, stellar flares, atmospheric erosion, and strange climate patterns. A planet may have one side facing the star and one side trapped in permanent night. Life might survive near the twilight zone, where light and darkness meet, but settlement would be complicated. Suppose instead the ship chooses a sun-like star. That sounds safer emotionally, but sun-like stars are not identical. Age matters. Metal content matters. Planetary architecture matters. Giant planets can protect inner worlds by shaping asteroid populations, or destabilize them by throwing debris inward. A system can look orderly for billions of years, then suffer chaos because of slow gravitational interactions. Suppose the ship chooses a wider region near Andromeda's disk, where stars are abundant. More stars mean more options, but also more hazards. Massive young stars pour out ultraviolet radiation. Supernovae occur more often in star-forming regions. Gas clouds can disturb motion. Dense environments bring close stellar encounters over long timescales. A habitable planet in a lively region may be less safe than a less perfect planet in a quieter neighborhood. Every choice becomes a compromise. The final approach to a candidate system would be one of the most emotional stages of the entire journey. For the first time, instruments would not be mapping distant galaxies or abstract structures. They would be measuring possible air, possible oceans, possible seasons, possible ground. Spectrometers would look for atmospheric gases. Telescopes would study reflected light. Gravity measurements would estimate mass. Transit data, if possible, would refine radius. Infrared observations would hint at temperature. Magnetospheric signs might suggest protection. The ship would scan for moons, rings, asteroid belts, radiation belts, orbital resonances, and anything that could threaten arrival. If a planet looked promising, people aboard would probably become afraid of hope. Hope is dangerous after an impossible journey. It can make disappointment feel like death. The first image of an Andromedan planet from close range might become the most important image in human history. Not because it is guaranteed to show blue oceans or green continents, but because it would prove that humanity had reached another galaxy and found a world large enough to be more than a dot. Imagine a planet turning below the ship after the crossing. Maybe it has clouds, maybe not. Maybe its surface is rust, ice, methane haze, black volcanic plains, or global ocean. Maybe it is too hostile to land on, but beautiful enough to make people cry. Maybe it is not the answer. Even failure would be overwhelming, because it would be failure in another galaxy. If the ship found no safe world at first, survival would depend on whether it could continue searching. This is where the design of the mission matters again. Did the builders create a ship with enough endurance to wander after arrival? Did they build smaller probes? Did they preserve manufacturing systems capable of making replacement parts from asteroid material? Did the ship have the ability to refuel, mine, build, and adapt? Or was it only a one-shot vessel aimed at a destination too vague to guarantee survival? A terrifying journey does not end when the map says arrival. It ends when a stable future begins. Andromeda could offer resources, but not automatically. The ship would need to find them. Asteroids, comets, icy bodies, moons, and metal-rich debris might become the difference between a temporary visitor and a new civilization. A generation ship arriving in a star system would likely behave less like a passenger vehicle and more like a seed trying to become an ecosystem. It would send scouts. It would harvest material. It would build habitats. It would test atmospheres. It would map radiation. It would decide whether to land, orbit, divide, or remain mobile. That decision could define the next chapter of human existence. Landing on a planet may feel like the natural ending, but it might not be the safest one. A planet has gravity wells, weather, unknown chemistry, geological hazards, biological uncertainty if life exists, and limited control. A space habitat built from local materials may be safer and more adaptable. The descendants of the first intergalactic travelers might choose not to live on a planet at all. They might orbit an Andromedan star in artificial worlds. They might become a civilization of habitats, mirrors, farms, rotating cylinders, asteroid mines, and archives. They might look down at planets the way we look at oceans from cliffs. Beautiful, powerful, and not always safe. If alien life exists in Andromeda, the terrifying part becomes even deeper. Not because it must be intelligent, because even simple life would change everything. A microbe on an Andromedan moon or planet would prove that life is not only a Milky Way story, it would mean biology can appear in another galaxy under conditions separated from Earth by millions of light years. The discovery would be almost impossible to send home meaningfully because home might be gone or unreachable in practical terms. The people who found it would carry the knowledge locally inside their new civilization. Contact with alien life, if it happened, would create risks that no mission plan could fully solve. Contamination in both directions, unknown biochemistry, ethical questions, quarantine, panic, reverence, the decision to touch or not touch. A ship that survived intergalactic space might finally be stopped by the question of whether it has the right to enter a living world. That is a strange possibility. The journey could be completed physically, but not morally. And then there is the largest irony of all. Andromeda is coming toward us. The ship may be traveling to a galaxy that over cosmic time is already part of our future. For many years, astronomers expected the Milky Way and Andromeda to collide and merge several billion years from now. More recent work has made the future less certain because the motions and masses of the local group are difficult to measure precisely. The Large Magellanic Cloud, Triangulum, and other gravitational influences can change the prediction. Some simulations still favor a merger. Others leave a significant chance that the galaxies avoid a direct collision for much longer. This uncertainty makes the journey stranger, not less interesting. A ship heading to Andromeda is not traveling to a fixed island. It is traveling through a gravitational dance. The target itself is moving. The Milky Way is moving. The local group is moving. Space is expanding on larger scales, though gravitationally bound systems like the local group resist that expansion internally. The geometry of the future is not a simple line drawn from Earth to M31. It is a changing arrangement of enormous masses drifting, pulling, bending paths, and rewriting maps over billions of years. If the galaxies do merge one day, the concept of traveling from the Milky Way to Andromeda becomes almost poetic. The destination and home may eventually become part of the same larger galaxy. A ship that spends ages crossing the gap might arrive in Andromeda long before, during, or after a future interaction, depending on speed and launch time. If the journey is extremely slow, the galaxy it seeks may not look like the Andromeda we see today. Its disk may be distorted, star streams may be longer, its satellite galaxies may have shifted. If a merger is underway, the sky could be full of tidal tails, bursts of star formation, disturbed gas, and gravitational chaos. The travelers might set out for a spiral and arrive at a transformation. This is one reason cosmic travel resists ordinary adventure stories. On Earth, destinations wait. In the universe, destinations evolve. Andromeda is not a museum exhibit fixed in place. It is a living gravitational system. Stars are born. Stars die. Gas flows. Satellite galaxies fall in. Black holes feed and quiet down. Spiral arms change. Clusters disperse. Dark matter structures guide motion. The galaxy seen by the first crew through telescopes would not be identical to the one encountered by their descendants. A long enough journey means the map becomes history before the travelers arrive. Near the central regions of Andromeda, the dangers increase again. The bulge contains dense old stellar populations. The core hosts a supermassive black hole, not because Andromeda is unusual, but because large galaxies commonly have them. From far away, a galactic center can look like a bright nucleus. Up close, it is a crowded environment where gravity, radiation, stellar remnants, and orbital complexity make casual travel dangerous. No sensible mission would aim directly at the core unless science outweighed survival. The central black hole is not a monster vacuum cleaner swallowing the entire galaxy. Stars orbit around galactic centers because of the combined mass distribution, not because the black hole dominates everything at all distances. But nearby, the central region is still not a place for a fragile arc. Dense fields increase the chances of gravitational encounters. Old, compact objects are more common. Radiation histories are harsher. Navigation becomes more demanding. The safest hope would be a quiet region, not the core, not a massive star-forming nursery, not the edge of a violent young cluster. A calm star with stable planets in a region where the sky is rich enough to build from, but quiet enough to survive. That sounds simple, until we remember that the ship has crossed millions of light years to ask for something the universe does not owe it. The universe does not arrange safe harbors for travelers. It only follows physics. If the ship succeeds, the first permanent human settlement in Andromeda would be almost impossible to describe from an Earth perspective. It would not be a colony in the ordinary sense. It would be an extension of humanity beyond the galaxy that formed us. The night sky there would not contain the Milky Way as home. It would contain it as a distant galaxy, perhaps visible as a pale structure, depending on location and instruments. Children born there might learn that the Milky Way is where their ancestors began, not where they belong. Earth would become an origin story. The sun would be one ordinary star in a galaxy across a darkness no person could cross casually. The Milky Way itself might be a sacred direction. Imagine standing inside an Andromedan habitat centuries after arrival, looking through a telescope at a faint spiral far away, knowing that everything human began somewhere inside that glow. Every language, every song, every ocean memory, every war, every act of kindness, every first rocket, every mistake, every telescope, every city and every name for the stars came from there. That is the emotional weight of the journey. It does not only make Andromeda close, it makes the Milky Way distant. And perhaps that is the final terrifying truth. To reach another galaxy, humanity would have to become alien to its own origin. Not biologically, perhaps. Not immediately. But culturally, mentally, historically. The people who arrived would not have touched Earth. They would not remember weather except through teaching. They might have bodies adapted to artificial gravity, habits shaped by enclosed ecosystems, and religions or philosophies built around movement rather than land. Their home would be a vessel, then a habitat, then perhaps a new world under another galactic sky. They would be human, but not earthbound, and the old question would remain: was the journey worth it? If measured by comfort, maybe not. If measured by safety, almost certainly not. If measured by preserving a species, perhaps. If measured by curiosity, by the need to know whether our galaxy is the edge of human destiny or only the first birthplace, then the answer becomes harder. A journey to Andromeda would be one of the most extreme acts imaginable, because it would demand faith without superstition. Faith in engineering, faith in descendants, faith in records, faith in people not yet born, faith that a destination can matter to someone who never saw the departure, faith that a civilization can survive long enough to arrive somewhere no ancestor could truly picture. That faith is not soft. It is terrifying, because the universe gives no guarantee. The ship could fail between galaxies and become a dark object moving forever, neither Milky Way nor Andromeda. It could reach the outer halo and lose its last functioning reactor. It could fracture socially after thousands of years. It could find no planet. It could arrive during a period of galactic disturbance. It could discover life and be unable to touch it. It could become a civilization that no longer wants the dream it inherited. Or it could succeed. It could cross the intergalactic dark, enter Andromeda's halo, find a stable star, build habitats, preserve its archives, and light new windows under a sky no human eye was ever meant to see. That success would not make the journey less terrifying. It would prove how terrifying the universe must be for such a journey to count as victory. Because the distance to Andromeda is not just a number, it is a test of everything fragile about us. Our bodies, our machines, our memory, our patience, our ability to cooperate across generations, our willingness to accept that the people who begin the greatest journeys may never be the people who finish them. Andromeda looks peaceful from Earth because distance makes violence quiet. It floats in our sky as a soft patch, a faint oval of ancient light that can be seen from dark places without a telescope. But that gentle appearance hides a scale beyond comfort. It hides hundreds of billions of stars, a vast halo, a violent merger history, a moving future, and a journey that would erase almost every ordinary meaning of travel. To go there would be to leave behind the scale human beings were built for. A road trip ends with tired eyes and a motel. An ocean voyage ends with land. A mission to the moon ends with a return path. Even a journey to Mars still takes place inside the sun's familiar neighborhood. But a journey to Andromeda is different. It begins by turning home into a galaxy. It continues by turning the galaxy into memory. It ends, if it ends at all, by asking whether humanity can become something large enough in time to survive a distance almost no living thing should ever have to cross. The most terrifying part is not that Andromeda is far away. It is that Andromeda is close by cosmic standards. It is our neighboring giant, a nearby galaxy, one of the most obvious destinations beyond the Milky Way. And even that is almost beyond every human category of reach. That tells us something about the universe. It tells us that the cosmic map is not designed around us. The nearest great spiral is not near in any human sense. The space between galaxies is not a waiting road. The stars are not arranged as stepping stones. Every beautiful object in the night sky is wrapped in distances so vast that getting there would require not only technology, but new forms of civilization. So when we say the terrifying journey to Andromeda, we are not only talking about a ship moving through space. We are talking about the price of making the universe smaller. Every kilometer crossed would cost energy. Every year survived would cost discipline. Every generation born aboard would cost trust. Every memory preserved would cost effort. And every glimpse of the destination would remind the travelers that arrival is not the same as belonging. In the end, Andromeda may not be terrifying because it is hostile. It may be terrifying because it is real, a real galaxy, with real stars, real histories, real dangers, real possible worlds, and real distances between us and it. From Earth, we can see its light with our own eyes. That is the beautiful part. But the light that reaches us took millions of years to arrive. That is the terrifying part. We can look at Andromeda tonight and touch it with vision, but not with hands. We can photograph it, measure it, model its motion, and imagine its planets. We can place it in stories and simulations. We can even predict pieces of its future with the Milky Way. But to actually go there would be to challenge the deepest boundary between seeing and reaching. The journey would teach us that the universe allows knowledge long before it allows contact. It lets us see across the dark. It does not easily let us cross it. There is another reason the arrival would not be simple. Andromeda is not only far away, it is enormous in more than one direction. A galaxy is usually imagined as the bright spiral we see in photographs, but the visible disk is only the part that glows easily. Around it lies a much larger envelope, a halo that can stretch for hundreds of thousands of light years. Some observations suggest that the gaseous halos of the Milky Way and Andromeda may already be interacting in a very loose sense, not as bright stars colliding, but as enormous clouds of thin material reaching into the same local group environment. That means a traveler would not arrive at Andromeda the way a plane arrives at a city. There is no gate, no atmosphere, no line painted across space. There is only a slow change in ownership. At first, the particles around the ship may still feel like the background of the local group. Then, they begin to belong statistically to Andromeda's extended halo. Later, faint old stars become more common. Then streams, clusters, and dwarf companions become part of the surrounding sky. Long after that, the bright disk still waits ahead, wide and structured. But the galaxy has already begun. This kind of border is unsettling because humans like edges. We like doors, coastlines, fences, horizons, and maps that say here begins another place. Galaxies do not care about that need. Their borders are probability fields. Their outskirts overlap with darkness. Their identities are written in gravity, motion, chemistry, and history rather than invisible walls. So the travelers might ask the same question for centuries. Are we there yet? And the honest answer would be strange. In one sense, yes. In another sense, not even close. That uncertainty matters because the ship would have to decide when to change from crossing mode to arrival mode. Crossing mode is about conservation. Everything is protected. Every maneuver is expensive. Every gram of mass has a reason. Arrival mode is about exploration, construction, risk, and choice. A civilization can remain in crossing mode too long and become afraid to live. It can enter arrival mode too early and waste the reserves that kept it alive. Between galaxies, caution is survival. Inside a new galaxy, caution can become paralysis. The first probes sent into Andromeda's halo would probably be small, patient, and disposable compared with the main vessel. They would survey nearby stars, search for small bodies, test dust densities, measure magnetic fields, and listen for natural radio emissions. If the mission carried autonomous factories, it might try to build more probes from captured material. If it lacked that ability, every probe would be a treasure. A single probe lost to dust, radiation, or malfunction would not just be a failed instrument. It would be a vanished scout in another galaxy. The main ship would need information but information would cost exposure. To map a system, something may need to enter it. To study a planet, something may need to approach. To collect material, machines may need to land on asteroids or icy bodies. Each step away from the ship increases knowledge while creating new ways to fail. This is why the journey to Andromeda would become less like sailing to a far continent and more like moving an entire city through a dark wilderness, where the wilderness is made of vacuum, radiation, gravity, and time. And the people inside that city would not be passive passengers. They would be gardeners, mechanics, teachers, pilots, doctors, archivists, farmers, judges, programmers, engineers, and children. A generation ship cannot survive as a machine alone. It survives as a culture that knows how to maintain a machine. If the culture becomes careless, the hardware eventually follows. If the hardware decays, the culture loses the physical world it depends on. During the crossing, the people might live by strict routines, recycling cycles, radiation drills, agricultural checks, structural inspections, education schedules, birth planning, conflict mediation, medical screening, archive ceremonies, engine maintenance, course updates, sleep cycles artificial enough to feel normal only because no one aboard remembers anything else. But, as Andromeda approaches, new tensions appear. A society built around preserving a ship may not be the same society needed to explore a galaxy. Some people would argue for caution, saying that the ancestors survived because they never wasted risk. Others would say that the mission had not crossed the dark, just to remain sealed forever. Some would want to study for centuries before settling anywhere. Some would want to choose the first acceptable system and stop the wandering. Some would prefer multiple settlements, spreading risk. Others would fear division because a small population split too early might not survive. The first political crisis of Andromeda may not be caused by aliens, black holes, or hostile worlds. It may be caused by the question of what arrival means. That is a powerful thought because it makes the journey human again. Cosmic distances are so large that they can make people feel irrelevant. But inside every giant journey, ordinary human problems remain. Trust, fear, leadership, memory, hope, anger, exhaustion, the need for meaning, the resentment of inherited burdens, the desire to choose one's own life. Andromeda would not erase those problems, it would magnify them. Even the sky could become political. One group might see the Milky Way behind them as sacred, a symbol that must guide every decision. Another might see it as the past, a beautiful origin that should no longer control the future. Some might want to preserve Earth languages exactly. Others might naturally create new ones. Some might keep old calendars. Others might count years from departure, from the first intergalactic crossing, from arrival in Andromeda's halo, or from the first settlement. Over enough time, a mission becomes a mythology. That can keep people together. It can also trap them. The universe outside would keep applying pressure, regardless of what they believed. If the ship entered a region with more stellar debris, the shield would need repairs. If a local star produced strong flares, habitats would need protection. If a chosen planet had an unstable climate, people would need to adapt or leave. If a new resource deposit was found, arguments over ownership could begin immediately. If the population had remained too small, genetic planning and medical technology would become central to survival. If the population grew too large, carrying capacity would become a crisis. And there would be no Earth government to appeal to. No distant authority could understand conditions in real time. The ship would become law, territory, government, history, and home, all at once. By the time it reached Andromeda, the old distinction between spacecraft and society might disappear completely. That is why the most important technology on such a mission may not be the engine. It may be governance. A broken engine can end a journey quickly. Broken governance can end it slowly, through decisions that no repair manual can fix. The ship must know how to change without forgetting what must not change. It must preserve enough tradition to remain coherent and enough flexibility to survive the unexpected. A rigid society might crack. A society with no continuity might drift into chaos. Somewhere between those extremes is the thin path that lets a mission live across time. The closer Andromeda becomes, the more the travelers would also confront the possibility that they are not the only ones who ever attempted such a crossing. This does not mean there must be advanced alien civilizations waiting. It means that any galaxy with hundreds of billions of stars raises the question. If life can become technological elsewhere, then Andromeda has had its own opportunities, its own habitable zones, its own old stars, and perhaps its own histories. The silence would be meaningful. If the ship entered Andromeda and detected no artificial signals, no engineered infrared signatures, no unusual beacons, no obvious altered star systems, that absence would feel different from the silence heard from Earth. From Earth, Andromeda is distant and faint. From inside its halo, silence becomes local. It stops being a philosophical puzzle and becomes the environment around you. Maybe intelligence is rare. Maybe it destroys itself. Maybe it stays quiet. Maybe it uses technologies we do not recognize. Maybe it lives in places we do not think to look. Maybe the time windows almost never overlap. A generation ship arriving in Andromeda would not solve the question of cosmic loneliness immediately. It might deepen it. To travel all that way and still hear only natural radio noise, plasma, stellar activity, and the machinery of one's own vessel would be a heavy kind of answer. But the opposite possibility is even more destabilizing. A signal, not a message understood at once, not a dramatic voice welcoming the travelers, perhaps only a narrow band emission from a distant region. A pattern that does not look natural, a pulse repeated with strange precision, an infrared excess around a star that suggests engineering, a moving object whose acceleration does not fit a comet, asteroid, or spacecraft from the ship. Even a hint would change everything. After millions of years of thinking of itself as the only mind in the crossing, the ship would have to decide what caution means in a galaxy that might already contain someone else. Do they answer? Do they hide? Do they observe for centuries? Do they change course? Do they risk revealing the existence of a fragile population far from its origin? The terrifying journey to Andromeda could become terrifying not because the destination is empty, but because it is not. And if it is not empty, then every assumption fails. A ship designed for survival and settlement may not be designed for diplomacy. A society raised on old human stories of contact may still be unprepared for the reality of another intelligence shaped by another star, another biology, another history, and perhaps another million years of development. Even peaceful contact could be dangerous through misunderstanding. Even distant detection could cause panic. Even the decision to remain silent could divide the ship. This is why the journey cannot be reduced to propulsion. Engines get you moving. They do not tell you what to become when you arrive. Andromeda would also force a new relationship with time. The travelers would live in a galaxy whose light reached Earth before many human ancestors existed. Every star they approach has been shining through a history that unfolded separately from ours. Its planets may have gone through ice ages, impacts, extinctions, ocean formation, atmospheric loss, or biological experiments while Earth evolved life, intelligence, and technology far away. To enter Andromeda is to enter a parallel cosmic biography. Not parallel in a mystical sense, parallel in history. While trilobites moved through ancient seas on Earth, Andromedan stars were aging. While dinosaurs walked under the sun, Andromedan planets were orbiting their own suns. While humans learned fire, painted caves, built cities, launched spacecraft, and mapped the cosmic microwave background, Andromeda remained overhead, already full of worlds that had never known us. That realization gives the journey weight. The ship is not traveling into a blank future. It is entering a place with its own past. A past no human was there to witness. A past recorded in rocks, atmospheres, orbits, stellar populations, and, perhaps, fossils if life ever arose there. The first human scientists in Andromeda would become archaeologists of a galaxy that had been visible from Earth all along, but unreachable. They would read chemical signatures in old stars. They would compare Andromedan star formation history with the Milky Ways. They would examine whether planets formed differently in different regions. They would learn whether the galaxies' mergers made life harder or simply more varied. Their work would not be a side mission. It would be the reason the journey mattered, because survival alone is not enough to justify crossing the dark. A civilization could survive in habitats inside the Milky Way with far less cost. It could spread to nearby stars, build around red dwarfs, mine asteroids, and wait out stellar lifetimes without ever crossing to another galaxy. The reason to go to Andromeda is not only safety. It is knowledge, expansion, redundancy, and the refusal to let one galaxy define the boundary of possible human experience. That sounds grand, but it is also dangerous. Grand ideas often demand sacrifices from people who did not personally choose them. A child born near the edge of Andromeda may ask why their ancestors left a galaxy full of stars to chase another one. The answer may not satisfy them. The mission may have sounded heroic at launch. After centuries of repairs, rationing, and inherited duty, heroism can feel like a burden. That question must be part of the story, because any honest journey to Andromeda is not only about what the universe is like. It is about whether humans can ethically ask future generations to finish dreams begun before they existed. There is no easy answer. Without long commitments, no intergalactic mission happens. With long commitments, freedom becomes complicated. The ship would need ways for people to live meaningful lives, even if arrival remained distant. It would need art, study, work, love, privacy, community, ceremony, and room for disagreement. It would need more than survival protocols. It would need a reason to wake up. That was not always the destination. A journey that offers only a far future will eventually starve the present. The people aboard must have a life during the crossing, not only after it. This makes the ship itself part of the destination. For many generations, it would be the only world they ever know. Its gardens would be their forests, its water systems would be their rivers, its observation decks would be their mountains. Its engines would be distant thunder, its archives would be continents of memory. Its hull would be the line between existence and the dark. By the time Andromeda fills the sky, some may love the ship too much to leave it. Others may hate it because it kept them alive at the cost of every natural horizon. Both reactions would be understandable. Andromeda would not simply be the end of travel. It would be the beginning of choosing what home means after home has become impossible to return to. And maybe that is why Andromeda matters so much. It is close enough to feel like an invitation, far enough to feel like a warning, beautiful enough to pull the mind outward, distant enough to remind us that wonder and terror can come from the same light. The ship, if it ever existed, would keep moving through that lesson. Behind it, the Milky Way would fade into a memory of origin. Ahead, Andromeda would become structure, then halo, then systems, then choices. Around it, space would remain vast and indifferent, carrying the quiet pressure of time. And somewhere inside that impossible crossing, the travelers would understand something no telescope alone can teach. A galaxy is not just a place you can see. It is a lifetime multiplied until the word lifetime breaks. It is a destination so large that even arrival has layers. It is a reminder that the universe is not empty because nothing is there, but because everything is separated by distances that change the meaning of existence. And if humanity ever makes that journey, if a ship from the Milky Way ever enters the realm of Andromeda and survives long enough to call something their home, the achievement will not only be technological, it will be historical, biological, cultural, almost mythic. It will mean that a species born beside one ordinary star learned how to carry itself across the dark between galaxies. Not quickly, not easily, not without loss, but far enough to prove that origin does not have to be the same as limit. And that may be the final meaning of the terrifying journey to Andromeda. Not that the galaxy is waiting to destroy us, not that every star there is dangerous, not that the darkness between here and there is evil, but that the distance is so immense, the time so deep, and the transformation so complete, that reaching Andromeda would force humanity to become something capable of surviving the scale of the universe itself. And by the time the journey ends, the travelers may look back at the Milky Way, look ahead into Andromeda, and realize that the terrifying part was never only the road. It was becoming the kind of civilization that could take it.